Hello, this video is about base units versus derived units. So as you know, the SI is based on just 7 base units. They are the kilogram, meter, second, ampere, mole, Kelvin, and candela. Base units are the ones whose magnitudes are directly defined by the SI. So what about the other SI units? So the rest are all called derived units, and their magnitudes are defined through the base units. So how does this work? Let's use the Newton as an example. So Newton is the SI unit for force. Now I want you to think of a formula that includes force. I think for most people, what comes to their mind is the formula F equals to ma. So what does that tell us? That means if I apply a force of 1 Newton on a mass of 1 kilogram, it's going to accelerate at a rate of 1 meter per second square. That means 1 Newton is exactly 1 kilogram meter per second square. So because the magnitudes of kilogram, meter, and second are defined, the magnitude of 1 Newton is also defined. Let's use another example. Let's try the joule, which is the SI unit for energy. So again, we need a formula that contains energy. We have quite a few options, but personally, my favorite is the KE. Everybody knows that KE is half mv square. So that means 1 joule of KE is the amount of KE that 1 kilogram of mass will have if it's moving at 1 meter per second. Now there's a v square here, right? So because of that, I have to square this thing here as well. Let's open up the bracket. So we have kilogram, meter square, and per second square. So that's what 1 joule is. 1 joule is 1 kilogram meter square per second square. Are you getting the hang of it? Okay, let's try one more. Let's try the volt, which is the SI unit for voltage. So we need a formula. Which one, huh? Something tells me that a good choice would be P is equals to V times I. So power is voltage times current. Now, what is the units for power? Watt, of course, right? Watt. The units for voltage is volt. The unit for current is ampere. Since we're interested in the volt, let's make volts the subject. So 1 volt is 1 watt per ampere. Now, what is 1 watt? Now, power is the rate of work done. So 1 watt is actually 1 joule per second. Now, what would joule be? Well, we have already worked out what a joule is. So I'll just copy it down here. So kilogram, meter square, and there's a second to the power of -2 and a second to the power of -1 here. So I'm going to combine the two of them, so I get second to the power of -3. And that's the ampere term here. So that's it. So 1 volt is 1 kilogram meter square per second cube per ampere. So do you see why we only need 7 base units for 7 base quantities? It's because all the other derived quantities are related to these 7 base quantities. So that derived units can be built upon these 7 base units. Alright, that's all. Ta-ta!